Or more accurately, I want the length of this vector here. Because, in fact, this is exactly d here. It's the same d as we have here. Okay, so how can I find the vector that goes from this point here to this point up here? Well, that is a projection. It is the projection of v onto the normal vector n. So that gives me the vector, but I want the length of it. And that'll be the d that I'm looking for. Okay, so that's the big conceptual thing here. Drawing a picture and deciding which projection you want. So don't be shy if you have trouble with any of this. I can do lots more diagrams, talk you through it. No problem. For now, let's move on with calculation. We get n dot v over n dot n. In the direction of n. And then what is that? What is n? Well, n can be extracted from the coefficients here. Okay, so the coefficients are 3, minus 1, minus 1. That's exactly my n that I can use. So I'm doing a dot product of n with the vector v, which I found over here. So what do I get? I get 6 minus 1 minus 4 over n dot n, which is 11. And I get 3 minus 1 minus 1. Length of that. Lovely thing. So 1 over 11, length of 3 negative 1 negative 1, which is root 11 over 11. Okay. So this picture is complicated. I believe for this scenario, this particular scenario, there is a formula that you can memorize that is in the textbook. I will also say that in the textbook, they go through this with a slightly different approach. So if you don't like what I'm doing here, you may want to see the textbook's approach. Okay, one more example for this section. Sorry, not one more example. We will do something where the point is the origin. Okay, I could probably draw this accurately with not too much effort, but I don't even want to put that much effort into it. So I'll just draw my line L. I will draw the origin, and then I'll ask myself, what do I want? Well, I want this distance. Right angle, of course. And I could say, well, look, there's a vector x0 that is on my line. And x0 can be any vector on the line. So just looking at this equation, I can go 2, 0 will work. Okay, that is a choice. You can do any vector on this line. And then I say, well, I want this d here. What is d? Well, it's the side length of this triangle here. So d is the e. D is, well, I gotta be a little bit careful because this vector here is, well, I don't know. I don't have it. But what I do have is a direction vector, where I can get a direction vector for the line, which we'll call u. So that's something that's parallel to the line. Looking at the equation here, I can see that minus 2, 3 is normal to L. So if I flip these and change the sign of one of them, I get a vector that is parallel to L. And I will choose that to be my U vector. Okay, now I see that the triangle I want to solve is actually this one here. So that's also D right there. So I'll look at this triangle and try to decide what I want. I want the perpendicular, some perpendicular, the length of a perpendicular onto U of the vector x0. Okay, because this would be the projection, and this is the perpendicular. Okay, what's that? So this is going to be x0 minus the projection. So what is x0 again? 2, 0. Minus the projection. So here's my u, here's my x0 I'm using. So just work this out. I get 6 over 13. Oy. And 3, 2 here. So what's that? Length of 2 minus 18 over 13, 0 minus 12 over 13.